When we are studying a pair of linear equations in two variables, first of all, we need to remember that it is a linear equation in two variables would be of the standard form of ax plus by plus c is equal to 0. Here you have a, you have b, you have c. These are real numbers. Real numbers. That's the standard form where a, b, and c are real numbers and both a and b cannot be equal to 0. Because if one of them is equal to 0, then it becomes a linear equation in one variable. Like 0x or 0y would make it just one variable. That's the standard form. Now, when you have a pair of linear equations, then you need to compare the ratios. Very easy to understand this. So the standard form of a pair of linear equations would be a1x plus b1y plus c1 is equal to 0. Then you will have that is your first equation, and your second equation will be a2x plus b2y plus c2 is equal to 0, which would be your second equation. When you compare these two and you compare the coefficients of x and the coefficients of the y's here and the constant c, you would get certain results. So these are your results. If you have a1 upon a2 is not equal to b1 upon b2, this simply means that number one, you will have one unique solution. Number two, the solution is consistent. Number three, the solution will give intersecting lines. The lines will be intersecting, which means that in a graph you would have the equation. One line would come this way and another line would come this way, and this point would give you one unique solution. This point would be a consistent solution, and this point here shows the point of intersection. It's very simple to understand. Now another condition would be that you would have a1 upon a2 would be equal to b1 upon b2 would be equal to c1 upon c2. In a case like this, you would have, number one, infinitely many solutions. You would have, number two, the solution is consistent but dependent. And number three, the solution would give coincidental lines. What does that mean? On a graph, If you have a solution coming this way for the first equation, then the second equation also would be on the line itself. So that's why it is called coincidental lines. So you would have infinitely many solutions. If you have one value of x, you would have another value of y. If you have one value of y, you would have another value of x. You keep on changing the values, then you will have a different value of the other variable. So that is why it is called infinitely many solutions, and the lines would be coincidental. You know, it could be here, it could be here, it could be here, any point along that line. Now the third condition is that if A1 upon A2 is equal, is equal to B1 upon B2 is not equal to C1 upon C2, then your conditions would be number 1, no solution. Number 2, inconsistent. And number 3, you would have parallel lines. And if we look at that, if we look at the graph, if you got one solution running here, you would have another solution running here. Which means that, not solution, you would have one line running here and another line running here, which is parallel to one another. And since they do not intersect, nor do they coincide, that means it would give you no solution. It would be inconsistent, and the lines would be parallel. So if you look at, let's say if we have 2x plus 3y is equal to 5, and then you have 3x plus 5y is equal to 7, you would notice that your A1 upon A2 means it is 2 by 3. Your B1 upon B2 would be 3 by 5, and you stop there. Why? Because since A1 upon A2 is not equal to B1 upon B2, then this one would give you this, which is having these conditions. Now suppose you have 2 upon 2x plus 3y is equal to 5, and then you have 4x plus 6y is equal to 10, then here you would notice that A1 upon A2 is equal to 2 by 4, which is equal to half. B1 upon B2 is equal to 3 by 6, which is equal to half again. C1 by C2 is equal to 5 by 10, which is again equal to half. Clearly you can see here that A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. This is as the second condition here, which means that you will have these results. Lastly, if you have 2x plus 3y is equal to 5, and then 4x plus 6y is equal to 7, you can see that a1 by a2 is equal to 2 by 4, which is equal to half. b1 by b2 is equal to 3 by 6, which is equal to half. And c1 by c2 is equal to 5 by 7. Clearly you can see that a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2. And this gives you the third condition here, all right, with all these results of no solution, inconsistency, and parallel lines. So with this, you would be able to understand how the equations work.